Hello, and welcome to another Orca 3D video tutorial. Today, we'll run a Halltrop analysis in Orca 3D, a parametric speed and power prediction included with the analysis module. The Halltrop-Menem method is a common way to predict the resistance of large displacement vessels. It's a regression-based approach, drawing on data from model testing and real-world results using a wide range of hull forms. Performing a Halltrop analysis is easy with Orca 3D's analysis module, which also includes the Savitzky analysis for planing hulls and the Van Ortmerson analysis for small ships like tugs and trawlers. Before using Orca 3D's Halltrop analysis tool, make sure you're familiar with the Halltrop method's limits. In addition to these, your model must be a symmetrical monohull, with the center plane at 0 in the transverse direction. If your vessel does not fit within the Halltrop method's parameter limits, is asymmetrical, or is a multi-hull, consider instead using Orca 3D Marine CFD. Simulation can provide highly accurate predictions for complex model shapes. Before starting the analysis, make sure to check these few things. Be sure that your model orientation is set correctly. Check this in the Orca 3D Properties window, accessible in the Orca 3D menu, or with the Orca Properties command. Now is also a good time to check your Orca units. Next, head to the Rhino document settings and check that your tolerance isn't too tight. It probably shouldn't be smaller than about 1/10 of a millimeter. Now, run the Orca Halltrop analysis command, or go to the Orca 3D menu, then to Speed/Power, then Halltrop analysis. Then select your hull. You can use a half hull or the full hull. Select only integral hull components, like the main hull surface or skegs. Users will have to calculate the resistance contribution of appendages, rudders, and struts on their own, or using Orca 3D Marine CFD. Right-click or press Enter to advance to the Input window. The first step here is to define your load case. By checking this option, you can use an Orca 3D fixed load case combined with the geometry you selected for hydrostatics in the last step. Use the mirror option if you selected a half hull for hydrostatics. Then, you can pick from your existing Orca 3D fixed load cases, and Orca will automatically update the hydrostatics. You can add and edit fixed load cases here as well. If you'd like to learn more about Orca 3D fixed load cases, take a look at the load case section of our basic hydrostatics and stability analysis video. Link down below and appearing now as a YouTube card. Certain values can be difficult to interpret for some geometries, such as the stern shape coefficient. Be sure to review these before starting your analysis. To change a value, uncheck the Use Defined Load Case button, then adjust any value you'd like. Next, set the speeds for the runs. Set a min and max and an increment. Remember that the Halltrop method's results are only valid for speeds with length-based Froude numbers under 0.8. Let's set a maximum speed well above that and see what happens when you run a test outside the method's limits. Next, you can define margins and efficiency. The correlation allowance accounts for the differences between model results and full-scale predictions, like the effect of hull roughness. You can define a custom correlation allowance, or select one from common values. Next, users can set the resistance margin to add in the contribution of appendages, superstructures, and any environmental factors. For propulsive efficiency, enter your estimate for losses in the propeller, shafting, and transmission. This figure is used for calculating the approximate propulsive power required for your vessel. Once you click Calculate, the report will automatically appear in a new window. You can access Orca 3D reports at any time by going to the Orca 3D panel, then to the Orca 3D Reports tab, and then clicking on the appropriate report. The report begins with analysis parameters. then shows hydrostatics, then lists results from each speed run. The prediction check highlights any speed that Orca 3D has flagged. Here's a flagged run, and by matching the check number to the notes at the end of the table, it tells us that the resulting food number is above 0.8. Speeds with prediction checks are also marked on the resistance plot. You can disable this by unchecking Show Checks in Resistance Plot in the Output section of the Analysis Setup window. Thanks for watching, and check out the Orca 3D channel for more how-to videos. Got more questions? Get more answers with the help resources in the description.